Let's discuss the solutions for the homework questions that you're supposed to do last week. Okay, the first question is to derive the structure of the secondary alcohol from the ketone. Okay, by reducing this ketone, this is butane-2-one, you will end up with a secondary alcohol. And how does this secondary alcohol look like? First, you got to find out that you got to note the position of the C double bond O, right? Replace this C double bond O with single bonds and put H and OH. You can reverse the positions of H and OH such that this carbon has 4 single bonds, and check again if this structure is a secondary alcohol. Now it turns out to be this is a secondary alcohol because it has the hydroxy group that is attached to the carbon is attached to only one hydrogen atom. Or you can look at it alternatively, that the hydroxy group that is attached to the C here, okay, this carbon is attached to 2 hydrocarbon chains or 2 alkyl groups or 2 R groups. So this is a secondary alcohol. Now a secondary alcohol oxidizes to form a ketone, that's the final product, whereas a primary alcohol oxidizes to form an aldehyde, and subsequent oxidation will yield carboxylic acid. Next question. This is the correct structure for propane 1,3-dioic acid. Okay, the term dioic tells us that there are 2 carboxylic acid groups, COOH groups, and they must be placed at the ends of propane 1,3. Okay, it must be at carbon positions 1 and 3. It cannot be position 1 and 2. Okay, if you place them next to each other, you will end up with the structure ethane 1,2-dioic acid. Now, ethane 1,2-dioic acid, if you look at the carbons there in this molecule, in this acid molecules, it has already attained octet configuration because it has formed 4 single bonds, right? 4 single bonds is 8 electrons. Each single bond is 2 electrons. So it's not possible for carbon to form more than 4 single bonds. So that is why it's not possible for either of these carbon to extend another single bond with carbon. And that is why propane 1,2-dioic acid does not exist.